as we have the information for the Mohr circle, which is the center, epsilon average 0, negative 25 micro 0, and the radius equal to gamma max over 2 is 106 micro inch over inch or millimeter over millimeter. So from that we can go ahead to draw the Mohr circle for this example. We can choose the grid so that we easy to draw. And in the stress, the Mohr circle for the normal stress it will be horizontal, and now it become a normal strain epsilon. So we can draw that line in. And then we also have the vertical line is for the shear strength. Shear strength. So let's put down the note here. You see epsilon, and units is micro inch over inch, for example. And in the stress, the Mohr circle for the vertical axis is tau, and as you can see for analogous, tau now for strain is gamma over 2. So as you can see now, the vertical is gamma over 2, not gamma, and the units is micro. So from that one we can, let's see, one grid in here, we make that is 25 micro. So we can be able to locate the center, negative 25, 0. It will be there. So let's write down that is the center, epsilon, normal strain, average, 0. That's the location. And the radius 106. So we can be able to locate the intersection of the Mohr circle with the horizontal and vertical axis. So with that we can have it intersection that you can see 25. So it will be here 25, another 50 from the center, 75 and 100. So it will be somewhere the 25, they'll go to the origins, and 25, 25, 100, and here 25, 25, 50, 75, 100. Negative 25, negative 50, 75, negative 100, and 106 micron, and gamma max over 2. From the center we can draw like here, so that the point gamma max over 2, 106 micro. And then of course we can go down to vertically somewhere there for the gamma max over 2. Now we can go ahead to draw the Mohr circle. That makes a perfect Mohr circle, as you can see there. So the intersection of the Mohr circle with the horizontal axis epsilon, So on the right side, it will be epsilon 1 principal normal strength, and the left side is principal normal strength epsilon 2. And of course, the gamma max is the vertical based on the axis gamma max over 2. So if you can see that this basically that is gamma max over 2, not gamma max, because the analogous of tau is gamma over 2, if you recall that. And then that one equal to 106 micro. And then we can be able to locate, because any point on the Mohr represent the state of the strain. In this case, of course, previous class we talked about the state of stress, and now strain. The positive x-axis, and here is the horizontal axis is the x. Then the plane is defined by the axis perpendicular to it. So the positive plane x plane axis is the vertical plane on the right. Similarly, the y plane defined by the axis y perpendicular to it, so that is horizontal plane, and the positive y plane is the top plane that we saw in this state of strains block. So with that, we can be able to locate the and based on the Mohr circle, as you can see here, for the positive x plane will be 50 micro for the epsilon, and gamma over 2, 150 divided by 2 is 75 micro. And at this, on the positive x plane, we see the vertical plane on the right, the gamma, the shear strain, it tends to rotate the blue block clockwise. That's why it's positive in the Mohr circle, and I also note that earlier in here. So from that, we can be able to find out the location for the x. It will be there, and that one is the x plane, positive x plane, and that coordinate is 50 positive and 75 for gamma over 2. Again, it's gamma over 2, not gamma, so that is micro. And for x, that is x plane, so you just have one correct, and the other, the y plane, you just from x draw a line, go through the center and go through the other point, and that definitely that is the y plane. And the y plane, which is the horizontal plane, and the coordinate, as you can see here, is 100 micro negative. That's why it below the horizontal epsilon axis, and negative 75 micro. So here, negative 100, negative 75, unit in micro. So you have that, the x plane and y plane. Then we can be able to locate all of other location of the plane for the principal normal strains and the maximum shear strength. How can we do that? Always start at the x plane. So the x plane here, and you can see from x plane. So from here, move an angle counterclockwise to the vertical gamma max over 2. That basically either 2, everything is times 2, and you can see 2 theta s shear strength. And then we can also determine the angle from the x plane to the epsilon 1, that is 2 theta p1. And again, similarly, we can have the theta from the x plane to the epsilon 2, that we have is 2 theta p2. And if we have the protractor that like I show you in worksheet 12E in the previous lesson, we can be able to measure the angle directly. And again, what you read in protractor is 2 theta p1, 2 theta s, and 2 theta p2. And the others, you can see that 2 root in here, 2 theta s1, and the other one, and you can see here, is 2 theta h2. So 2 root for each, and you can see there. So as you can see, 2 theta p1 plus 2 theta p2 is 180. That's why p1 and p2, that is the two orthogonal axes 1 and 2, because that divide by 2, 90 degrees. Similarly, 2 theta s1 plus 2 theta s2, as you can see from the Mohr circle, it will be 180. That's why the two angles for s1 and s2 is always 90 degrees. And you have 2 theta s1 plus 2 theta p1 equal to 90 degrees. So theta s1, theta p1 equal to, divided by 2, 90 divided by 2 is 45 degrees. So as you can see, the principal normal strain, or previous lesson, principal normal stress, and the another plane that have a maximum shear stress in the previous class, or the maximum shear strain in this class, those two add together it always 45 degrees. So as you can see, for example here, theta p1 plus theta s1 equal to 45 degrees. With that, we done for the Mohr circle. Give that example at very important when we use the analogies in from the stress transformation to strain transformation. Both equation, use equation, analytical method, or Mohr circle.